All right, so hi everyone. Are you able to hear me and see my screen clearly? Wonderful, wonderful to have all of you in this discussion. Today, what we're going to do is today we are going to do very important thing. So in the last session, what we learned was how to build a model from scratch. So we took a toy example and we walked through the number of steps that are needed. And what we're going to do today is how to take that model to the live as in production, right? So again, those who are very new to these sessions, let me give you a recap. First of all, welcome to the session by CloudxLab. In this session, what we do is we take a real example and walk you through the entire project. You can do this project by yourself at CloudxLab at later point of time. I'm going to show you how. And what we are going to do is we're going to basically walk through the various steps in a project, right? And once you are finished with the project at CloudxLab, it automatically generates the certificate. So you don't need to worry about certificate being generated on this chat or anywhere. All you need to do is at later point of time in your own time, do this project by yourself and the certificate will be generated for you. All right. And that you can share with everybody. All right, let's get started. So a brief about CloudxLab. At CloudxLab, what we are trying to do is we have a cloud-based lab where all the tools and everything related to big data, DevOps, machine learning, and AI, all of that tools are available for all. These tools are not proprietary tools by CloudxLab. These tools are generalized tools which anybody can install and use. The value that CloudxLab brings is that number one, it provides you all the tools at the cloud so that you don't have to worry about installing on your desktop, installing a lot of tools like Hadoop, Spark, R, Python. All of these tools are very hard. Therefore, what we have done is we've installed it for you. You can just log into CloudxLab and start using it. And since it's a costly affair for us, we have a very tiny fees per month that you can take a free lab and then you can sign up for that. You will find a lot of content at CloudxLab. If you go into explore courses, you will find lots of content around various topics. Also, there are courses that CloudxLab runs. These courses are well integrated into the platform, and these courses are from the top colleges of the country. And the added advantage at CloudxLab is that when you are solving a project, it will evaluate every step of yours, and then it'll give you a go ahead. It's like having an instructor watching over your shoulder to guide you all the time, to nudge you all the time, so that you all get hands-on. In today's world, being hands-on is the most important thing, right? Um, so essentially what you do is no matter which company you work for, no matter where you work, whether you are a manager, you are executive, you are a junior engineer, intern, the thing that the industry has started realizing is that the individual needs to be hands-on. If and basically that's the sole idea behind CloudxLab. Our entire philosophy is about experiential learning, and therefore every concept, every idea has a supporting exercises that you have to do in cloud-based lab. I'll just walk you through a couple of things. If you if you go for, say, Linux, for example, okay, here you will find, I'll just select not guided project. Okay. So you can see that in here, there is a Linux basics. Now, if you take a look at this particular, topic, there are like around 90 exercises in this. And you can basically, what you can do is you can just go to any exercise. So there are small theory things. Then there are multiple choice questions, and then there are exercises. So let me take an example of, say, creating directory. Okay, so you have to create the directory on the right hand side. Only then it will give you the points. And that's the sole philosophy around each of our courses that we have built. Now, going back to where we started. So when you do things on the right hand side, you will get this scores. Now, we are going to do this very often. And in this project, this is what we are going to do. All right. Now, moving ahead. So today's topic is, now let's get back to the topic. Today's topic is, around guided projects. So guided project is nothing but a set of steps to get something practical outcome. Okay. Basically, this is guided because the system checks your work at every step and nudges you and gives you the feedback immediately. That we have seen in past that most of our learners have excelled in their career because of the guided projects. All right, so let me just select a guided project. Okay, and let's just select, say, deep machine learning. Okay, so these are the various projects that you have here, and I'm going to pick one project out of it. All right, so not these, not these, not these, not these. Probably I will go for, all right. So yes. So this is the project for today. What we are going to do is we are going to, right? All right. Okay. All right. Let me just unselect this. There was a better project. I want to take a better project today. Okay. One is this. Okay. And other is this. Let's just take a look at more projects. All right. Let's move ahead. Yes. Okay. So, all right. So let me also take a look at if we promise something else. Building image classification with pre-trained Keras models. Okay. All right. So this is a project that we are going to take today. All right. So, I mean, a question from Frank is, when you complete a guided project, can you include it in your personal GitHub repo? Of course. The code that you generate is yours. You can add it in your own personal GitHub repository and publish it. All right. So this is the project that we are going to take today. And it's essentially what we're going to do is we are going to do image classification using the pre-trained Keras models. The project aims to impart the knowledge on how to access the pre-trained model. And basically, we get the pre-trained ResNet model from Keras, and that's the whole idea. I'll just give you a brief overview on what it looks like. So basically, when we say machine learning, right? Machine learning is figuring out, right? Using the algorithms to figure out a mental model, right? If let's say a few years back, or say in 80s, if you had to do this, okay, you had to do what we are aiming to do today. Okay, let me just give you one more perspective. Okay, so if let's say this is the project, what we are going to do is we are going to take a model and do the image classification, right? So what is, I'll talk to you step by step. So what exactly is machine learning? What exactly is machine learning? Machine learning is all about figuring out the rules automatically using algorithm and using algorithm based on the past experiences or example data, right? That's exactly what is machine learning, right? Earlier, if you had to do this work, like let's say you have to do image classification, what exactly is image classification? Image classification is given an image, classify it uh, into something, okay? Into whether it's a cat or whether it's a dog, whether it's an animal, and so on. So classifying an image into a part. Okay, here we are going to talk about image classification in more details. So given an image, we have to classify it. So that's the core idea behind this project. So if we had to do it manually, we will ourselves try to figure out a correlation between image color, image pixels, and ourselves write the code to mark it into one of the categories, right? That's called like the coding way of solving problem, right? But that is not very stable because if you write rules by yourself, the chances are that you will get the rules wrong, or the rules will become very high, too many. Therefore, the newer approach is using the machine learning, So I'll just draw this. So so basically, what we usually do is that we manually earlier we manually study the problem, okay, come up with the rules, come up with rules, then test the model, test the model, okay. If this model is performing really good, okay, if uh, if this model is performing really good, then we deploy it. Otherwise, we re-evaluate, right? Otherwise, we go back to studying the problem, okay? So you can say that here, let me just draw the diagram. So first, this is the step number one. This is the, right? This is the step number one, from here, and then deploy, right? And if you are here, if this is not working very well, okay, if this is not working very well, so what we do is we go back to studying the problem. So this is one, this is step number two, this is step number three, this could be four, or this could be four. Okay, so if this is performing very good, we go back. It does not perform very good, then we go back to here. So this used to be the, before machine learning, we used to do this, right? But later on, when the machine learning approaches came into picture, this step, coming up with the rules, okay, is done by the machines. So this became, this approach became, instead of this, it becomes like we have got data, we have got data, okay, and from the data, the algorithms are figuring out the model, okay. So these rules, the rules that the algorithm will come up with are basically something that we test and deploy, okay. So instead of manually coming up with the rules, we use algorithm to come up with the rules. Though we still study the problem, we still work on figuring out what are those like how to, which algorithm to use, which model to use, how to clean the data, how to frame the problem. All of that is still has to be done manually. This is the part that we studied in the last one. Now, if you see, this is kind of a T diagram, okay? This is kind of a T diagram. One is training. We call that training. By the way of training the machine, we figure out the model, and then we take this model and deploy it, okay? Deploy it. Now, the beauty about the current world, The beauty about current world is that the model, this training part that you see here, is being done by so many people around the world, and they are sharing their model with you. Okay, they're sharing their model to recognize faces, their model to recognize objects, their model to recognize language, the model to recognize sound and classify sound, and so on. If you are interested, these are called pre-trained model. If somebody else is training and they're publishing it, that's called pre-trained model. All right, let me, yeah. So I hope my voice is clear. All right. So those who are wondering that in case of CloudxLab, you have to activate free lab by the way of, right? So you'll have to make a payment of $1, which gets reverted. This is to ensure that we know our customer, because there is a chance that people start mining, do a Bitcoin mining on our servers, or they start spreading the virus or start scanning the network. So to avoid that, we have put a bit of restriction, in the sense that you will have to provide $1, like it's a transaction way, so that we know our user, and then it gets refunded. So that's for the free trial, because in our case, it's a kind of very important aspect. All right. So I hope, I know that it sounds like crazy, but in our case, since we are providing the entire environment, there's a bigger threat that we have. Okay. So this model that you see here is actually pretty interesting idea. This had changed the way we have, because training a machine on a problem and coming up with the model is actually very time consuming task. Therefore, what lots of people have done is they have created these wonderful models. What they do is you give them an image, and they will give you the results. Okay, so model is generated from experience. Model is generated from experience, like experience data of past, and then from that model you can feed the images, or you can feed the audio or whatever, and it gives you the results. All right, and this is what we are going to learn today, how to deploy a model into production. Before I move further, I want to just walk you through this new economy of the world. The way we thought about the economy earlier was that, okay, there will be big Bs who will only win the war in case of AI, but that's not the case. In today's time, you have lots of wonderful pre-trained models, and you can just search for those models by looking at model zoo. Okay, and the beauty about it is that a particular model could be trained using one framework. Say somebody is using Python, C++, somebody is using Java to train the model. And model is essentially a bunch of numbers, okay, that can be transported to another system. And there it can be loaded and used. Therefore, it does not matter using which kind of processor, which kind of programming language, which kind of framework, whether it was PyTorch or TensorFlow, it doesn't matter. Okay, given a model, if you know the structure of the model, you can load it in any language, and then you can use it in your production environment or in your backend tasks. All right, so I'll just show you that there is a model zoo. Okay. All right. So yes, today we are going to use one of the pre-trained models, and I'm going to walk you through it. All right. So I'm just describing what it means by pre-trained model. Pre-trained model, like somebody took example data, photos or experiences and so on. And what they did was they trained they trained the model. They used the algorithm looked at the experiences, it came up with a mental model to do something. Like for example, this open pose model, what it does is, given the photo of the person, it will return the key points in your body, like elbow, shoulder, and things like that, right? So you can just load it and then use it. So this is an example of pre-trained model. Okay, so right? So it represents the first real-time multi-person system to jointly detect human body, hand, facial point. So if you use this model using, say, any of the models, like most of these models are interchangeable. You can use them in different places. All right, using different frameworks. So like OpenPose is a very good one. So for example, this open pose takes a photo of a person, tells you the joints, where are the joints in this photo. Similarly, if you take a look at like this one, mask RCNN. So what it does is, does is, in a photo, it generates the bounding boxes and segmentation. Segmentation is the boundary of the person in the image, and basically this is you don't need to learn as such how exactly it was trained, or you don't have to wait for months for the training. Here you have this model. What it does do is, given an image, given an image, it'll draw the boundary or the surrounding what do you say, the periphery of the whole object or a person. All right. Similarly, you will find right, lots of models that you can right away use, and that's the beauty about today's time. Like here, there is a WaveNet. Using WaveNet, you can start classifying the audio generation. Now, the other beauty about these models is that you can take the model, customize it, and retrain it. Okay, it's like in an army, if you need people in army, you take a sportsman who are good, trained at running and in the motor skills, and then you customize it a little bit in order to be able to aim and do other things. Exactly, that's the economy of today's time. So you take, let's say you want to hire a journalist, like the person who writes an article on medical terms, right? So what you do is, you take somebody who is from literature background, retrain them, and retrain them with new vocabulary, and they're good to go with further, right? Training somebody from scratch is very hard. Somebody who doesn't know that particular language is very hard. Therefore, that's exactly the same economy. In today's time, what you do is, let's say you have to build let's say, medical terms inference, right? Giving a description of the disease in medical terms, identify the medicine to be used, right? So what you'll do, you will take a language model which is pre-trained, and then retrain on your medical terminology. Now you have a model which understands the medical terminology, slightly retraining, and then you start feeding it your description. It'll convert the description into certain numbers, and then you can retrain. You can create another model which takes those numbers and and classify those numbers into something, into a disease. So the another term that you will need to know when you are dealing with most of the models is embeddings. Okay, so like for example, face recognition system. If you are using a face recognition system in which basically given a photo, identify it's the same person or different person. Now the beauty about this is that this pre-trained model is so powerful. What it does is it converts every face into a bunch of numbers. These numbers individually may not make sense, but the distance between set of numbers and other set of numbers will be very small. Okay, if the person is same, like my photo with glasses and without glasses will have like I loaded the pre-trained model, gave my face, it took the photo, and then I removed the glasses. Then I again gave to the pre-trained model that this is my face, this is a new photo. It'll convert it into numbers. So we got two set of numbers, two list of numbers. Okay, two list of numbers, and you can subtract them and take a square of each difference and sum it up. That score tells us the similarity, between one person and another. Okay, and that's a beauty about it. So embedding is list of numbers. Okay. Similarly, for sentiment analysis, what people have done is we've created these GPT models, these complex models. What they do is, given a sentence, they will convert this sentence into a bunch of numbers. Now, using those numbers, you can create further pipeline. Okay. Further, you can create further complex models and so on. So those in our last session, some of you asked that if the input data is text or image, how do we convert it into features? Using these pre-trained models. So using pre-trained models, convert your data set into features like list of numbers, and then you create your own model. And that's the beauty about today's world. So usually in a single system, you will have multiple flows of training, inferring, and so on. And that's how most of it is done. So let's say you want to build a model which converts, say, an Indian language into another Indian language, right? But you don't have the data, don't have the model right now, and it'll take a lot of time if you start training from the scratch. So what you do is you take a pre-trained model, you put 2 layers on it, a slight customization, and then you start feeding these samples of translation, and it will do a good job. Okay. And that's the power that we are talking about today. Like, for example, let's say I want to automatically generate the voice, my voice from a text, right? So I'll take a pre-trained model which converts the text into voice in general, and then I'll train it on my voice, and then it'll become custom. So we can take a pre-trained model and retrain it, or we can pick a pre-trained model and just use it as inference. And so that's exactly the whole idea, or the whole economy of the machine learning or AI is today. Okay, so you will use bunch of models in a single pipeline. There will be multiple models that will come into picture. All right. So now you can take a look at, say, modelzoo.co. This is quite popular, and there are many other websites which do a lot of things. Like this one is great. This is a pre-trained model to convert the video into some good analytics. Okay. Similarly, you will find a wonderful set of models. Okay. Do take a look at that. And other than that, you will also find these GitHub repositories where you will find lots of pre-trained models. Okay, so just search for Model Zoo, or just search for pre-trained model. Okay, those who are wondering what is this ONNX? ONNX is Open Exchange, in the sense that you can open neural network exchange. So it's a standard format, so that something trained in one framework can be loaded in another. So it's a midway model, or you can say a midway translation, or you can say ONNX is a format, open exchange format, whereby one model can be translated into a general model, and everybody every language, every framework will have a way to translate it. All right, but keep in mind that model is nothing but bunch of numbers, right? And those who are aware of neural network, it's essentially the basically the strengths of the lines that are connecting each of these neurons. Okay, or we call them weights. Perfect. So what we learned is that algorithm converts the example data into model after training, right? And model can be used in the production time to do the inference, right? Whether it's face recognition, voice recognition, translating text to voice to text, looking at the video and identifying the people, looking at the sound and identifying the person, and so on. You can almost do every magic without doing too much of training. That's the beauty about today's world. All right. A common question that I usually get when I'm basically speaking at various conferences. So a common question is that we are a startup and we don't have too much data, and we don't have too much of power, like computing power, to do the training, because training takes like months sometimes, and it requires like powerful GPUs and so on, and it might require like thousands of computers. So we are a startup and we don't have that kind of capacity to do the training. What to do? The beauty is that in today's time you have the pre-trained models. All right. So that's why this session today is a wonderful session. So let's get started. So So basically, the project imparts the knowledge on how to access a pre-trained model. Here we'll get the pre-trained ResNet model. Okay, ResNet is one of the architectures that was very popular. And okay, a question from Frank is, are there any guided projects on retraining pre-trained model? I plan to build those, okay? And if you want to do it, you can do it on the platform. I would love to support you. And we, like me and my team would love to do it. And though that's in pipeline. Okay, so probably in one of those the coming Wednesdays, we'll do this. All right. So essentially, we also use a term called transfer learning because we are transferring the learning from one place to another in the form of a model. Okay, and those who are not aware of that, these strategies on pre-training, embedding, this is what got the Nobel Prize in 2019, I think 2019 or 2018. Nobel, as in the Fielding Prize. In there was this computing prize given to three researchers, and it was around this. Okay, because it had changed the way we look at the world. All right, now instead of earlier people's skill. Right. All right. Earlier, people's skill was to delegate, get like if you think about the British period, or think about the ruling period, at that point of time, the strategy for the war or strategy of survival was to be able to delegate and do this or that. Right. In today's time, it's about figuring out which model to retrain, which model to customize, which model to reuse, and so on. Okay, so that's a core idea, and in today's time, that's the strategy for the war. Okay, not only for the war in the sense, in today's time, the war is all about economy, in the sense that we all flourish, and coming back to it, when we are building, let's say autonomous vehicle, it's all about figuring out which pre-trained model to use and how to use those. Okay, and that's the beauty about today's time. So and no matter where you are in the world, all of this knowledge is accessible to everybody, and the only limitation is what all we can think. Okay, the only limitation is knowing what it is, and basically applying those to solve your life problems. Okay, now basically the skills that will develop is TensorFlow 2, Python programming, and deep learning. All right, so even if you are not very conversant with Python, stay in the session. I would try my best to keep all of you updated with what we learn. All right, so great, wonderful, and let's get started. Okay. Right. Like, for example, thank you, Sherry. So one of the other things is that, those who are wondering, like, let's say there are handwritten forms, right? You must have seen those handwritten forms around the world, in which you basically, you have like bunch of forms and you need to convert that into data, right? Now, how do you do that? How do you do that? So the better idea is that you basically use a pre-trained model. Take a look at the pre-trained model of Tesseract. Okay, in my opinion, Tesseract has done wonderful job, and the accuracy is better than most of the professional ones. Okay, so here they have now, earlier Tesseract was rule based. It was not like this kind of machine learning, the way we have now. So now they have migrated. The newer versions are about, you can see that. So it is a neural network, the deep neural network. And basically, using Tesseract, by retraining Tesseract for your problem, you can do the scanning of lots of text, lots of different kind of forms. So take a look at this, as well as take a look at, say, YOLO. Okay, so these are some of the wonderful things that have happened in recent past, and I want to make sure that we all understand what we're talking about. There's so many things that there is YOLO, and there was Model Zoo, and then there is Tesseract. And so do take a look at all these terms after this session and study it in more detail. So if you take a look at this, okay, so this is a wonderful pre-trained model. And okay, this is something that you would love to see. Okay, this is like one of my favorite videos. Okay, I hope. Grammarly provides suggestions for grammar, spelling, style, tone, and more. Oh my, I'm just showing you the ads. I hope. Okay. All right, I need to switch into an account which is. You created a business. Now, create videos for your. Okay, so look at this. So it's a YOLO V3. It's already very popular. You can see that. So you can use this library for your own use. All right, and it's a pre-trained model, so you don't have to train, and it'll do the entire job for you. Not only this, one more important thing I wanted to mention is that using YOLO, you can retrain the model for your own set of classes, own set of objects. Even like we wanted to convert a image into extracting, like there's a book and there are exercises in the book, and what we wanted to do was extract the questions and options from it, right? And that was an example where we used the pre-trained model of YOLO and retrained it to identify from where to where is the question, from where to where is the option. And like with the very small data, it was able to perform really, really good. If we had trained it from the scratch, it could have taken a lot of data and a lot of time. But since we had a pre-trained model which can identify objects and things, it was very quicker to retrain it. All right. So that's the beauty about the pre-trained models. All right. So those who tried to do machine learning from scratch and got depressed that, okay, it takes too much of time, it takes too much of um, data, and we need to get the data and so on, they don't need to worry that much because lots of things are out there that you can just use. Okay. All of that knowledge that you gain out of training your model could be used in loading and retraining an existing model. All right. So take a look at these couple of ideas and let's go back. Okay, so what we're going to do is we'll be using ResNet 50, which was originally trained to classify ImageNet data. We shall use this model to predict the class of an input image, right? And we shall understand the different steps of pre-processing the input image as required by the network. Okay, so though I have done it multiple times, in case you want just 2 minutes of recap of how neural network works, I can do that. Okay, so right, you can think of, for a moment, you can think of a very complex machine. Okay, here this side we feed an image. Okay, my handwriting is very bad, so I'll basically just type text. Okay, so you feed an image. Okay, and from this side, from this side, it will give the class. Okay, and I'm going to be very abstract, but I can tell you that this will build your hunch about, okay, class such as cat, dog, human. Okay, so we feed an image, and this black box, we call that neural network, gives us these, right? So how does it really work? Okay, how does it really work? The way you can imagine a neural network is it has lots of knobs. Okay, it has lots of knobs in it. Okay, lots of knobs, like thousands of knobs inside it. And right, and each image is being fed to one of these knobs as the input. And these knobs are connected and so on. Okay, like that. Now, think of it that this is a black box, called neural network. It's not a lot of knobs. Okay. When we say train means that we give an image, and also we tell that this is a cat. And now the neural network, what it does is it strategically tweak these knobs such that the image gets converted into a class. Okay. Class is nothing but a number 0, 1, 2, 3, like that. Okay. So we tweak the image, we basically tweak the knobs. The algorithm called gradient descent or backpropagation tweaks these knobs strategically or cleverly or greedily such that this image gets converted into these numbers 1, 2, 3. Okay. And basically when we keep on feeding it more and more image, different kind of class, these knobs get into a shape where it's able to convert an image into a class. Okay. That's how you can think about how does the neural network works. Okay. And take a look at the backpropagation from scratch if you really want to understand how the whole training works. And just if you search, I have done it earlier. So those of you who really want to understand what is going on with this, so I wrote this tutorial on backpropagation from scratch. Okay. Try this out. Okay, this is going to be quite useful to all of you, those who really want to understand how does the neural network get trained. Okay. So neural network is just bunch of these knobs. These knobs are nothing but these numbers, right? They are represented with the numbers. So, and like they are, when it comes to like ResNet, they are billion knobs. Using billion knobs, we are able to translate an image into class. Okay, and this configuration of these knobs is what we call model. Okay, if you take a look at the data, you'll find that, okay, this has these many layer of knobs, and these knobs are connected to this one, each knob at this position, and so on. And that's essentially how you can imagine a neural network. Neural network is bunch of knobs that have been tweaked in order to give an output. All right. So now you can imagine that if each knob can move by 10 angles, and if there are billion knobs, how many permutations can you make? 10 to the power of billions, right? And that's crazy, right? Therefore, a greedy algorithm like backpropagation is smarter to figure out the knob permutations really smartly. Okay. So you will find out that the neural network is essentially a black box with lots of knobs in it, which are already tweaked by somebody, and you got this preset of knobs. It's like a machine that you got, which can convert an image into a class of objects 0, 1, 2, 3. Okay, and that's about it. That's ResNet model. All right. I hope I was able to convey some idea. All right. So essentially, what ResNet does is ResNet converts an image into a category of object. All right. So what we're going to do is take an image and do that. All right. So it says that let's import the module. So we are importing, first of all, NumPy as NP. Okay. So this NumPy is essentially a big array list of numbers, like a data structure. Instead of using Python's default, we are using NumPy's array, and that's a de facto because it's really fast. It's really efficient. There are new ones, but NumPy is the standard today. Okay, so now moving ahead, yeah. Vali Devi, I had actually shared it above by Sandeep Giri. That's me. Okay. So I'm Sandeep Giri. If you guys can find it me on LinkedIn, feel free to send me a request. Okay. All right. So just mention that you attended the talk. Okay. Um, so first of all, this particular exercise asking us to import NumPy as NP. Okay, I have done that. Now import TensorFlow as TF. Okay, not a big deal. So we'll just say, and I think it's better to type TensorFlow as TF. TensorFlow is the module. What it does is it provides you all kinds of algorithms, all kinds of ways to train a neural network, tweak these knobs, load the pre-trained model, and so on. Okay, perfect. Now, it's taking a bit of time. You can see the asterisk there. Now it's loaded. Now let me load Keras from TensorFlow. Okay, we'll say from TensorFlow import Keras. Okay. All right. They are basically, you can say packages or modules in Python. We are importing them. And Keras is a nice API, which is part of TensorFlow. Previously, when TensorFlow launched, the TensorFlow 1 was a bit clumsy. Earlier, we taught lots of people on TensorFlow 1. I kind of was okay with TensorFlow 1 because it gave more control, but it was like just too much. Okay, so then they came up with a neat API called Keras. Keras was an open standard, and they did a nice thing to adapt it. All right, that was one thing that saved TensorFlow, guys. TensorFlow is now is basically by Google, and all right, now let's import matplotlib. Okay. All right. So this library is for plotting. This library is for array. This library is for the algorithms and the model. And this library is for plotting the charts and other things. Now, then we are going to set the seed. Why do we set the seed? To make the results predictable. Okay. So whether you are training or doing other things, it is a good practice to set the seed so that because there's a lot of randomness involved in training and predicting. Okay, there's a lot of randomness. Therefore, to make the results reproducible, like you did something and it's not working, and then you message me, hey, it's not working for me, it's working for you. And to avoid that kind of thing, we generally set a seed. Or sometimes what happens is that one time it works for me and other time it did not, and then I realize, oh, it's because of the randomness that got introduced, because all of these knobs that you see, they are initialized randomly in the beginning. Okay, and by setting the seed, that randomness goes away. Every time they'll be initialized with the same value. Okay, so in case of neural network, there's a lot of randomness, as part of design. All right. So now, since I have imported everything correctly, it let me move to the next one. Now it's asking me to import image from this particular package. So we're going to say from this. I know that this is not really going to be a challenging task, but it makes you do things. It makes you, it ensures that you just don't watch just like a television. Instead, it would force you to do things so that you can own the entire thing. And I believe that this is the best way to learn. Even if you have no clue what you're doing, you will learn a lot of things. All right, import this. All right, so now, okay, let's take a look at what we did. From this pre-processing package, we imported a module called image. Similarly, from this ResNet, I talked about the ResNet model, right? ResNet is a complex model. It won the it won international the competition couple of times. There was an international competition for image object detection, and here we are saying import this particular module from this package and import it as my model. Okay, so this contains the model. All right, now from this, we are going to import pre-processing input. So ResNet also provides these couple of functions that are needed for image processing in the beginning. Okay. Now get the model and include the weights of ImageNet data classification task. All right. Now this is an important task. Please pay attention to this one. So this is where I am initializing the model that I imported. This is the ResNet model that I imported. And I'm saying that load these weights. Okay. Load these weights. So what it's going to do is it's going to download that data. It's going to download the weights from the internet and try to load it. Okay. Therefore, it will take a bit of time. All right. You can see that. Now, those of you who are wondering, how would you do it in the production environment? This is where you have to take a call, because here, it downloads as well as it creates the neural network. That black box that I talked about, that thing it creates now. Okay. So if you are doing it in a web application, you do not want to do this over and over, right? Every time request is coming, you're loading the model. No, what you have to do is you have to keep it ready. So you have to keep this service as such. Okay. So here, what we are saying is that whatever pre-trained model was, we are loading it as is. Okay. So these weights is essentially those knobs that we talked about in a big, if you think of neural network as a big box, a big black box to which you give the image and it gives you the output. This black box is made up of these knobs inside it and the layers of these knobs, the way they are arranged. And essentially those are called the weights. Knob positions are numbers from 0 to 1, are decimal numbers. Okay. And those numbers, not only always 0 to 1, but usually they are 0 to 1. Okay. So like a decimal number. So that's how you can think of those weights as a bunch of numbers, like array of numbers. All right. So that's the weights. And this is a pre-trained model. Somebody trained it. Somebody tweaked the knobs, came up with a perfect set of knobs, gave it as a package in this Python. And when we are loading that, it basically bringing it from the internet, and it's creating a neural network right now. So this is the model. This guy is the model which will do the inference right away. All right. Let me see if I pass. It's going to check all these variables in the notebook, and only then it'll let me go. Okay, so I did not make a single mistake. If I do it without doing anything and just submit the answer, it'll throw an error. Okay, it says invalid or undefined IMG. Okay, so next thing is we are going to let's say take a look at this image. All right, so this is the image. Okay, this is the image. And let me just copy this image. This image is located at a central location. You won't be able to find it in your console just like that. So you have to copy it from this central location. Okay, using exclamation mark. Using exclamation mark, you can execute any Linux command. Okay, so here I'm saying copy this to my home directory. Okay, so I'm saying this. All right. Now, let me go to my files. Okay. So I copied using Linux command in the Python notebook and copied that to my home directory. Let me just sort it by last modified. So you can see line. If I click on that, you can see this is the image that we have given the path to. Okay. All right. So this is the image path. Okay. So this line, the one that you saw, is the image that we are going to process. All right. So now here it's saying that ResNet needs input in this size, and this size was way higher, right? If you just save this image to local and just take a look at this, let me just download it, and let's just see. Okay. So we have, you can see the dimensions of this image is very high, right? We need to change it to this size, because the neural network expects those many pixels. Okay, so now right, this model is the black box for us, which will take an image, give an answer, and for that we need to translate this image so that we can change it. Okay, so here what you see is this is the code. Okay, let me see if I can solve this. It says, so load the image using image.loadImage. Okay, okay, image.loadImage. Pass the image path, fine, and target size this. So good news is this function, if you take a look at, in case you want to know what's going on inside any function, at any point of time, you can say help, and then you can just paste this. Okay, so it says that, right? So load image is essentially loads an image into PIL format. PIL is the Python library, PyImage library. I think PIL, I forgot the like full name, but never mind. So PIL is the standard format that everybody talks in when dealing with the images, especially in Python. Okay, and now what you have is essentially this function. It says that it returns a PIL instance, and it raises these errors, and it basically takes the path. It takes the grayscale. If you want to convert it into, instead of colored, we want to convert it into grayscale, we could use that. Instead of this one, we would use any of these. Right now, we are just loading it as is. Okay. Now, default is the RGB color and so on, right? And where is the target size? Yes, here is the target size. Okay. Yes, thank you, Frank. PIL is for Python image library. Perfect. So here we go. So this is essentially the target size. When we are loading, then this is the image that we have here. You can see now it's loaded like that. Okay. Also, you can take a look at the shape, not shape. All right. We can also take a look at what are the various help documentation on this image object. Let me just scroll down a bit. So right. So you can see that there are basically it represents an image object to create the Pi object and so on. Right. So you can go through this documentation, and that's the beauty about fiddling around with things, that you will be able to find out all kinds of function it has. In Python, you can basically press dot and press tab, and it'll give you the autocomplete. If you don't like that one, you can use dir. It shows you all the functions on that image. Okay, and try figure that out. So this is essentially the added advantage of doing hands-on, because this will give you a way better learning and a unique path of learning when you fiddle around with things. Okay, so now we got the image. So now let's view the image. Okay, so we will convert the image to NumPy array using this. Okay, so of course it was like Jupyter Notebook was pretty smart to do this, and okay, so you could actually use image show, img show, or you could just say right, np.as array. Okay, so when we using NumPy, you can convert any image into bunch of numbers. Okay, and yes, of course. So one of the cool part about numbers is that you can do lots of magic with that. Like, for example, if you think about an image, what exactly is a colored image? Colored image is a three-dimensional array of numbers, not two-dimensional, three-dimensional, because third dimension is your color, right? Third dimension has only three values, RGB, and that's the color. And the two dimensions are the X and Y values, right? On each value, there are three values and so on. So you can think of the image as 3D object, okay? And that means that okay, so that means that a colored video is a four-dimensional object. Okay, so you can also do this, right? And the beauty is either you do not, I mean, by default, Jupyter understands that format and is able to show you. So now the image is essentially like an array, okay? The IMG object is essentially like an array, or you can convert it to pure array using np.asArray. And PLT IMShow converts an array into an image object, okay? So this essentially is the idea. Now let's see if this model works or not, okay? So, right now, what we are going to do is we are going to convert this image, okay, using NP as array, or you can just say img dot image dot img to array. There are multiple ways of doing it, okay? So now if you see, take a look at these x, okay? It's a bunch of numbers, right? And you can see the dimensions, 1, 2, 3. And to understand the dimensions of it, you see, this is the image, okay? Just, right, if you take a look at this, this data, it is three-dimensional, right? So the first pixel is this one probably here, okay? And you can see the values are really dark, okay? And if you take a look at the first row, just first row of this data, you can see the first row, this is first color, and so on. As you see, as you go ahead, probably here somewhere, it starts to become lighter. You see that? It starts to become lighter. All right. And then again, it starts, right? It starts going back dark and lighter. Okay. And so on, right? So probably somewhere here, if you take a look at 150, probably, okay. So probably here, there'll be really, really light colors somewhere. All right, never mind. So you give it a try and figure this out, okay? So you will see like super light colors and so on. All right. So like there will be one point here somewhere. This is going to be 175. Yeah, let me give it a try to one. Yeah, I think somewhere here it'll be like super light 255, 255, 255. Okay, so basically this image is represented as numbers, okay? And the X is essentially very standard way of looking at the numbers, okay? Those who are asking, is it possible to change the resolution? Of course, you can do all kinds of things. If you want to just convert it into grayscale, what you can do is you can say mean and access equals, say, 2, okay? So you can see now it's two-dimensional data set. And if you say, right, plt dot imshow, okay. So this is now black and white. You see this? Kind of, you know, the color is gone and it has tried to impose the color and so on. So basically what I'm trying to say is that the lots of things you can actually, you know, do this. You can change the colors, you can do other kind of things. So that's a beauty about manipulating an object as numbers, okay? If you want to change the zoom, what you can do is take an average of each window and create it. So basically zoom the image, okay? So those kind of things you can do when you have the image represented as numbers. So that's added advantage of doing hands-on, that you can fiddle around with the image and see how it looks like, okay? So what we did was we created an X. X is essentially, when we talk about machine learning, always we basically do instance is a single row of features, right? Here, the features are the pixels values of the picture, right? So the input instance is usually called as X. Bunch of instances, like multiple instances, are called capital X, okay? Y is usually used as the outcome, the label, all right? So that's a kind of terminology, but it's not mandatory, okay? All right. Now, this model expects it to be, so this is the, right, it wants it to be pure, Now, now let's say pre-process it. First, we convert it into an array, then we are pre-processing it. Okay, so we can, because we imported this function, remember, from the Keras library, the ResNet library. So now we have pre-processed this X. Okay, pre-processed probably is averaging it out and doing other things. Okay, and let me see if this, how does it look? PLT IM show. How would it look after pre-processing? Looks like it can't handle it. Okay, because it has negative numbers, right? It basically created some kind of average of values and so on. Okay, so or if you want to figure out what pre-process input does, is you can just say help pre-process input. Okay, so it's a wrapper function here. It did not give any documentation. Okay, now is the, now we are done with pre-processing. Now notice that the output of X, the processing of output of X is again assigned to the X. So X is the one that contains this pre-processed input. Now is the time that we call our model. What was the name of our model? My model dot predict, right? Was that the name? Let me go up. Let me go up. What was the name of our model? Where did we initialize it? Here. It's model. This is the class, and this is the instance of it. So we are creating an object of this one, assigning it to this one, and we are saying model.predict. Okay. Now these predictions are, you can see, now these are bunch of numbers. You see that? These are bunch of probabilities. Okay, let me just show you, right? Sorry, let me just take a look at the shape of this. Okay, so it has 1,000 categories. Okay, do not panic at this point of time that you wanted it to print lion, but it gave you this array. Okay, now the important part is that the ResNet object, ResNet model, is a classifier. It classifies an object into bunch of classes, 1,000 classes. So it'll give the probability, of an object, if it'll give the probability of an object which are found, right? Whatever objects are found in the image, it will give that as 1, others as 0. Okay, let's take a look at threads again. And since it is 1 by this, I can take a look at like 0th row. It has only 1 row. Now the thing is that this one is crazy. Okay, you can see it's like 10 to the power 12 minus 12. That means it is not really has found. So how do we figure out which of the value is 1? So one way is that right, one way is that we say for I in right, enumerate. Okay, enumerate threads, and just code it quickly and say if v is less than this or greater than this. Okay, if the value is greater than this, we print the I. All right, it says that the truth value of an array with more than one element is ambiguous. Okay, so all right, now let's just see threads. Okay, I have to just convert it into, all right. So looks like only one of these values, 291 index, is the one that is less than right, threads. Sorry. Oh, this one has like high probability. You see that, close to 1. Okay. If there were multiple objects, there'll be multiple points where it'll find. Okay. Those who are confused about this, what I'm doing is I'm going over this list instead of manually trying to hunt it down. I'm just going over the list, right? So 290 will be 290 by 4 is how much? So around 70 somewhere. Okay. All right. All right. Yeah. So you can take a look at that one. But I just wrote instead of manually going through, I just wrote a loop which will go through this list and figure out if something is greater than this value and print that index. Now, luckily, there's only one, and it's like super confident. It's like super confident and so on. Then yes, you can do the max, of course, but you won't be able to know. You won't be able to know where was it found. Okay. Okay, so there is np argmax, np argmax. Okay, np argmax does the same thing. Okay, np argmax does the same thing. So this loop is what uh, basically finds the index of the value which where maximum is found. Okay, so when we say max, it gives the max value, but index of that one you have to do argmax. Okay, so all right. Now there is a function that it gives. Luckily, this is we imported from ResNet. It is essentially decode predictions, and you can see this one goes through the labels and looks at the 291 index, and it's lion. It says that lion's probability is this much. Okay, and interesting. The see orangutan is 10 to the power minus 5, and chow is 10 to the power minus 5. Okay, if I did this, then it probably would give this much. Is 10. All right. So here I'm saying that give me top 3, and this is how it is. All right. So I can just say, all right. So essentially, this is one. This is the one maximum, and then okay. So I hope this made sense to all of you. And so essentially, there's a list of categories, like marking each of the columns, and from there you can find out that 291 index is essentially reserved for lion. Okay. All right. So what we did simply is imported ResNet, imported various functions like preprocess and decode, and then loaded an image, fed that image to the model that we created. Now the model gave us list of probabilities, marking each column reserved for one animal or one object, and then and there are 1,000 columns, and we figured out that based on like which one is the maximum, and we found out that it is a lion. All right. So we can try some more things. Do I have some good images? Okay. And all right. Let me just download, let's say, what do you call it? Balloon? Okay. Let me take good images from there. All right. Okay. Or let me take something, you know, give me suggestions. What should I look at? Okay. Not lion. I want to do it like cake or something. All right. Or let me just take a look at party. Okay. No, this is not. I just want to see like, okay. Let's take a look at the things that it finds in this one. Okay. So I'm going to copy this image. Or this one is good. This one is better. Okay. I'm going to see what all it comes up with. Okay. Okay. So what I'm going to do is I'm going to go here. All right. And upload an image. Wait, this one, right? Click on upload. I just uploaded it in my home directory so that I can do some experiments. And I'll just copy this name. Now go back to my notebook. All right. Now I'm going up here. And all right. All right. Or do you want me to just create a function? I think I should just create a function. Okay. I'll just create a function. So image path is this. All right. And okay. So I'm just creating a function called def print objects. Okay. And this guy is going to take, let's say, image path. Okay. It's going to take image path. And from that image path, it will load the image. Then it's going to, we don't need this. We just need this. Okay. And then we move ahead. Okay. This one. Then we move ahead. What else do we need? We need pre-process. Okay. Then we need predictions. Yes. And then finally, we just need to predict the results, right? So, and that's about it. All right, let's take a look at whether our function works or not. Okay, so we are going to say this, and we are going to just call it with this line, right? So you can see that it has loaded it and done it, right? Now it's pretty simple to just call it with our own. All right, I'll just copy it again. What was name again? Copy. All right, and I'm going to say tilde because it's in a home directory. It says not found. Okay, probably I'll have to give slash home slash Sandeep Giri 9034 and then try again. You can see in this image that you see here, it's not opening. In this image, it is found some lab code. Okay, this one is like lab code. Okay, and some fur code. Interesting. Okay, and then unicycle. It's confused with some unicycle. Okay, and so on. Anyway, so it did not work that well. Let's try something else. Okay, let's try with this one. Okay, let's see if it works, how well it works. Okay. Anyway, you can start experimenting with it. Okay. And there. All right. I just want to see something interesting. Okay. Let's see how it looks. Okay. I'm just saving this so that I can. All right. All right. Okay. All right. Hey guys, if you really want certificate, just finish this project and you'll automatically get certificate. Okay. So yeah, there'll be a better way to get a certificate and more authentic way. Okay. Now I'm going to try this out. Did it upload? Interesting. This time it figured out there's a balloon. Then there's an airship. Interesting. And then there is a parachute. All right. So I hope this was useful to you. Let's try. All right. That's it. Wonderful. So that was pretty simple, pretty simple. But this opens a lot of ideas. Okay. This opens a lot of ideas, lots of you can try experimenting with all kinds of models this way. Okay. And feel free to experiment with those. Make yourself confident of using any of the pre-trained model, customizing those models, and use them in your advantage. So one of the things that I want to take up in future, there are a couple of things that I have in mind. One is retraining. Okay, one is retraining. Okay, that is one. Number two, or you can say retraining and customizing. Number two, I want to take a face recognition system. Okay, recognition system. And what we will do is we will, and number three, we'll build a web app, Flask-based web app. Plan was for today, but I think there are some changes. So we will basically in the next session, what we'll do is we'll try to build a Flask-based web app to do the face recognition. Okay, to do the face recognition. All right. In case in case you can't wait for this or this, so you can just go to explore courses, and there are projects already which you can try it out. All right. And then next thing I want to do is optimize the number three. Okay. So this is what I'm going to do. So the idea is that this Flash-based app that we'll create, whenever users request is coming, we are doing inference, loading the model, and everything. How we can make it perfect and make it fast so that the latency is less than half second. Okay, so that's what we're going to do in this exercise. And few more ideas we have is around how do you customize face models. Okay, so those things is what I have in mind. If you guys have more ideas, do drop them in the comments and so on. And all right. A question from Zuan is that, do you have any project on crowd counting? Okay. The projects on crowd counting is pretty simple. You can just use YOLO in CloudxLab, and then you start, using that for crowd counting. It's pretty straightforward. All right. And there are some more models that you can retrain to do the crowd counting. I'll keep that in mind. I'll just make a note of it. Okay. Or we can say object counting. Okay. In general. So we'll create one such project. And do drop it in comments on our YouTube channel. This video is going to be available as a YouTube video. And feel free to drop in the comments. And can you also have a project on classifying face expressions, as I said? Oh, yes. Yes, Frank. So you can actually just, right? So we'll just say facial expression. Okay. Probably one sentiment analysis. Okay. And probably, right? Wonderful. So yeah, there was a question that what is the monthly fees? Monthly fees is very tiny. And please note that it doesn't auto deduct from your account. Okay. So you will have to renew manually because we wanted it to keep it such that it doesn't deduct automatically. And so you can, all right. So yes, I can add OCR retraining because we recently did it for a couple of customers. So we would love to do that. All right. So we will create that project in this. And so somebody said about the lab. So you can go to the lab page. Okay. And you'll find the pricing down there, right here. It's pretty basic. I mean, this is just to cover our costs of Google Cloud and Amazon Cloud. So I hope people would not mind paying that kind of basic fees. And yeah, so cool. These are pretty neat ideas. We'll try to do these uh, in future. All right. Wonderful. I hope I know that this was super fast pace, but I'm sure that you would right. You would love to you would have loved to learn about machine learning, how to use these models, and so on. Now, question is, how do you allow to use more than one GPU? Actually, we don't have GPU. The environment is for practicing and trying it out. If you want to do GPU, probably you'll have to buy proper another server, because if we allow GPU, suddenly there's a threat of mining, and people start mining, like Bitcoin mining, and that becomes right. So how should we certificate for the project submission? I think there is a link that is shared in the comments above. And all right. So okay, my team will share the link if they're around. Probably they'll share soon. Okay. So wonderful, wonderful. So thank you everyone. I really loved. Right. If you have more ideas, right, let me know. Also feel free to subscribe and share our YouTube channel. It's actually something that is pretty useful to people. And on CloudxLab you will find you will find lots of things, right. You will find basically there's a simplified machine learning tutorials. There are something that people really like. There are I think this is the most simplified way of representing how machine learning actually works. and and there are like big data tutorials that you might enjoy. So feel free to share and subscribe to the channel, as well as if you are and right, you can right. I'm sure that once you start liking the content and the lab, you will definitely go for some project or some course or something. Those who are interested in IIT certificate course, you can go ahead and buy those, or you can buy any of our courses. All right. So thank you so much. I hope this session was useful to all, and have a good day. Bye bye. All right. So one question is there from Frank: can the material be used? Okay. Let me just turn it off. Okay. I hope this session was useful to all, and have a good. Okay. So can the material in the GitHub repo be used in personal? Of course, of course. Yeah. This is not our property. This is all open source. You will definitely be able to use it. All right, Zuan, I'm very happy that you are from Barcelona. Nice. Most of our audience are like from, across the globe, and I'm very happy about it. So feel free to share with your friends. Thank you, Isha. Thank you. I'm not sure I'll be pronouncing your names correctly. Thank you, Zuan. Thank you, Sherry. Thank you, Frank. Thank you, Avdesh, Chirag, Vali Devi, and have a good day. Feel free to stay connected. I'm on LinkedIn, and stay connected. There are quite a few things that right are coming up at CloudxLab. Wonderful. I'm really happy that you guys liked it, and stay tuned till the next Wednesday. Again, in the next Wednesday, we'll take up our project and we'll do it. All right. Thank you, everyone. Have a good day. Bye bye.